Good morning, students. Today we'll discuss about more in differential equation for class 12th maths. Okay, so we have studied about the differential equation in my previous video. I have just explained the intro of differential equation, what is differential equation, and now we'll talk about its solutions. We have two solutions. One is general solution and other one is particular solution. Okay, particular solution. General solution means which contain arbitrary value, that is constant for parameters, but for a particular solution it gives a particular values to the constant terms, that is a and b. So now let us try to study, let us try to do some examples so that we able to understand about how we find the solution of a particular differential equation. Okay, so now let us try the questions from the exercise from the NCERT so that we able to understand about the how to find a particular solution. First we will talk about the particular solution of the differential equation. So now we have some questions. First question we have in my hand, that is they have given, that is y is equal to ex plus 1. Now they have given the first question we have y is equal to ex plus 1. Now this is a solution. Okay, now let us see, this given function is a solution of this equation. Equation we have y dash is equal to 0. So let us verify this function is a solution of the given equation or not. Let us see how we can do it. They have given y dash, y double dash and y dash, that is d2y by dx minus dy by dx. So first we'll find here dy by dx. We got here ex, that is we need to differentiate it with respect to x. Now we have done, we'll do it again. So I'll find this only, e raised power x. Now we have both the values, we can put here in this equation. We find ex is equal to 0 is equal to RHS. This is LHS we have taken. So we find that LHS is equal to RHS. So we can easily say that this function is a particular solution of this differential equation. So likewise we try to understand about it. Let us see with one more question so that it becomes more clear to us, that is how we find the particular solution of a differential equation. Okay, so now next we have in this y is equal to x square plus 2x plus c. Okay, now we have the equation here, that is y dash minus 2x minus 2 is equal to 0. So now we'll try to solve this. If I take dy by dx, I got 2x plus 2. Okay, now put this value in this. We got 2x plus 2 minus 2x minus 2. What I got here is equal to 0. So I can easily say that this is a solution, particular solution of a particular differential equation. Now let us try to say this, try to solve this one more. That is we have y is equal to cos x plus c. So now this is the we have this solution here, and now we'll say 1 plus sin x is equal to 0. Now how we can solve, let us see. First we need to find the differentiation first. So we have dy upon dx is equal to minus sin x plus c. Okay, so we have Now what we can do, so now we have dy by dx. So we have minus sin x plus sin x, we got here is equal to 0. So this is, we can say that this is a solution of a particular differential equation. So now we'll try to solve more. Okay, we have just solved only 3. Now we'll try to, now we'll try to solve the fourth question here. So now we have the fourth question. Okay, so now let us see how we can solve. Now we'll try to solve the fourth numerical. Now fourth numerical, we have y is equal to 1 plus x square, and we have here that is y dash is equal to xy upon 1 plus x square. Okay, so now let us try to solve this. We have y, so now dy by dx is equal to, if I differentiate this, but I will get half plus 1. You got 3 upon 2 upon 3 upon 2. Okay, so we have taken this, we have taken 1 plus x square like this, so we can do it. Now we'll try to differentiate this. So now what I get here, that is half 1 minus x square minus half into 2x. So I got minus also minus 2x upon 2, 1 minus x square under root. So I got here that is minus x upon 1 minus x square. So this is what I got here. Now what we need to do is, we can take, what we can do here, we can solve this. So if I have RHS is equal to x into y upon 1 plus x square. What we have x here? X we don't have, what we have y. 1 plus x square under root upon 1 plus x square. So we'll have x upon 1 plus x square under root. So what this we find, that is we have, so now we can say we got the same answer, that is equal to LHS. So we can say this is a particular solution of this. Now let us try to solve the next question I have. That is, the next question is, we have y is equal to ax. Okay, fifth question I have, y is equal to ax, and we need to prove, we have the differential equation y where x is not equal to 0. Okay, so now let us see how we can do it. In a very simple way, if I differentiate this, I got a. So now we have x into a, we have x into a, that is ax, and it becomes to y. So we have taken the RHS here, now it is LHS. So that is how we can easily find the particular solution of the differential equation. Now let us try to solve more in this case. What they have, now we have the next one, that is sixth, that is we have y is equal to x sin x. Okay, and here we have, now we have y is equal to x sin x, and we have the differential equation, that is xy dash is equal to y plus x square minus y square under root में, under root. Okay, so now we have this. Now let us, we have given the condition x is not equal to 0 and x is greater than y, or we can say x is less than minus y. Okay, so now we'll try to see how we can easily solve that numerical. Now what we can do here in a very simple way, first we need to differentiate this. So we will do it dy by dx. We have x into differentiation of sin x cos x plus sin x into differentiation of x will be 1. So we have got this now. Now we'll put this value here. We have LHS, that is x into x cos x plus sin x. Okay. So now we have x square cos x plus x sin x. We have. Okay. Now we'll try to prove in RHS also. What they have given, x into y plus x into x square minus y square. Now what is y here? That is x sin x plus x under root of x square minus, we have y x square sin square x. We got x sin x plus x, if I take square common, 1 minus sin square x. So I got here, if I try to solve it, x sin x plus x into x, we have taken x squared under root, so it will be x outside x into x squared, 1 minus sin cos square x into cos x. So I got my answer, x sin x plus x square cos x. So that is how we can easily find that this is a solution of a particular differential equation. Now let us try to solve more numericals from this exercise so it becomes easier for us. Okay, so now we have the next question. Now I have the seventh question. I have, that is seventh, I have xy is equal to log y plus c, and we have the differential equation, that is y dash is equal to y square upon 1 minus xy. Okay, so now we'll try to see how we can solve this. First we'll try to find a y dash. So y is equal to log y upon x. Now let us try to find the y dash. We have x into differentiation of y, log y, 1 upon y dy by dx minus log y, differentiation of x will be 1 upon, we have x. Okay, so now I have this, that is what we can do here. Now x upon y dy upon dx minus log y upon x is equal to y dash, that is we have here dy upon dx. Okay, so now let's try to do it more. And now we'll try to see how we can solve this. X into y dash is equal to x upon y dash minus log y. So now what we can do here, x y dash minus x upon y dash minus log y. Okay, we have. So now we can take x common here. Now what we can do here, we can take y dash common here. So x minus x upon y is equal to minus log y. Okay, so now I got this. So now what we can do here, if I take LCM here, we got y dash xy minus x upon y is equal to minus log y. Now y dash will be y into log y upon xy minus y. Okay, so I have got this y dash. Now let us try to solve this RHS first. We have y square upon 1 minus xy. So what is y? What is y? We need to take this log y upon x whole square upon y minus x into log y upon x. So I got this log y whole square upon x square upon we have minus log y. Okay, so I have taken this. Now what I will got here, if I do this log y whole square upon x square 1 minus log y. Okay, log y. So we can easily say we got this now. Wait, y square, we have log y upon x. Okay, so 1 minus log y upon x. So we got this log y whole square upon x square 1 minus log y. Okay, now let us see what we have done here. That is, we have given the solution, that is xy is equal to log y plus c. If we differentiate both sides, we got xy dash plus y is equal to 1 upon y dash. So now what I can do here, I can take that side common. So y is equal to 1 upon y dash minus xy dash. So I can take y dash common, 1 minus x upon y dash. We have y is equal to this. Okay, so now I can say y is equal to 1 minus xy upon y dash. So we got here y dash is equal to y square upon 1 minus xy. So now I put here the value y dash is equal to y square upon xy. And so we can say this is a particular solution of this particular differential equation. So likewise we solve such kind of questions. Let us take 2-3 numericals more so that we will be able to be clear with this concept. So now we have the question here, that is, we have done the 7th one. Now let us try to solve the 8th one. Now the 8th question we have, what is that? Y minus cos y is equal to x. Okay, and the equation we have this y sin y plus cos y plus x to y dash is equal to y. So now what we can do here, now very simple way to have given, let's try to solve this. We have y is equal to x plus cos y. If I differentiate this, dy by dx is equal to 1 plus, we will have 1 minus sin y dy by dx, or we can take that side dy by dx plus sin y dy by dx is equal to 1. Okay, so what can I do? We can take common here, sin y dy by dx is equal to 1. So therefore we got dy by dx, that is 1 upon 1 plus sin y. Okay, so now we can solve this by putting the value here. We will take first LHS, but we have y sin y plus cos y plus x. We have y dash, that is 1 plus sin y. Okay, so now what we can do here in a very simple way, we need to prove it to y, that is x plus cos y. Okay, so now here what we can do, y sin y. We can put a value of y here. That is x plus cos y into sin y plus cos y plus x upon we have 1 plus sin y. Okay. So now what we can do here, we can easily solve this. We can take x sin y plus x plus cos y plus cos y sin y. Okay, we have 1 plus sin y. What we can do, we can take separate it out, 1 plus sin y upon 1 plus sin y. Okay, like this we can do. Now we need to take cos y common, so we have 1 plus sin y. Okay, so likewise we can solve this. We got 1 plus sin y. So now we can reduce. Here also we got x plus cos y. That is got y is equal to RHS. Okay, so that is how we can find that this is a particular solution of this differential equation. Now let us try to solve the next question I have. That is the next question I have in this. We have ninth question now. X plus y is equal to tan inverse y. Okay, now we have this solution is given. So now what they have given is 8. We have, that is y minus cos. We have solved 8 numerical. Now we will try to solve the ninth one. They have given x plus y is equal to tan inverse y. Okay, and what they have given, the equation is this: y square y dash plus y square plus 1 is equal to 0. Okay, so now let's try to differentiate first. We got x plus dy by dx is equal to, now we'll see the differentiation of tan inverse y. Now let us try to say it will be 1 upon 1 plus y square into y dash. That is dy upon dx. So now what we can do? Take that there. So we got 1 plus y square minus 1. We have dy upon dx. Okay. So we have this y. If we differentiate dy upon dx, y into dy by dx. Now we have what we can do here. What we can do here, that is differentiation of x will get 1. So now we have y. So dy upon dx I have. So now what we can do, 1 plus y dash 1 plus y square is equal to y dash. So now if I multiply 1 plus y square plus y dash y square is equal to y dash. Okay, now what we can do, we have y square y dash plus y square plus 1. So it will be reduced. So we get y square y dash plus y square plus 1 is equal to 0. So we can say this is a particular solution of the given equation. So now we'll try to solve one more numerical, so that it will be more clear to us what they have given. Now the 10th question I have, we have y is equal to, okay, here we'll solve what they have given, that is y is equal to a square minus x square. Okay, where x belongs to minus a to a, and the equation is this: x plus y dy upon dx is equal to 0. Okay, so now where y is not equal to 0. So they have given this. So now we'll try to see how we can solve this. We will try dy upon dx first. Okay, so now we'll try to solve, that is dy upon dx. Now see what we can do here. We'll differentiate it. We'll got a square minus x square half minus 1 will have minus half into minus 2x. So I got this value minus x upon a square minus x square under root. Okay, so now this I got y dash. Now if I put here x plus y into y dash, that is minus x upon a square minus x square under root. Now what I have, x minus xy upon a square minus x square. Okay, so we have this. Now what is y? We can put here a square minus x square. Okay, under root we have into x upon a square minus x square. So I got what? X minus x is equal to 0. Okay, so that is how we can easily find a solution of a particular differential equation.